Nathan. Don't get discouraged about that quiz. You can't be perfect at everything. There's no doubt in my mind that you're gonna learn from that and not make those mistakes again. So don't get discouraged. Okay? All right. So here's the rest of the section 4-5's notes. So let's make sure we have it down. What are the 5 ways you can prove 2 triangles are congruent? Okay, so we got side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Remember, right triangle only. And in a proof, make sure that you do this. If you're going to use hypotenuse leg, you have to state that it's a right triangle before you can say that, because it is only good on a right triangle. So if that's going to be one of your reasons, you must first state that the triangle is, that the triangle is a right triangle. Okay. I'm looking at my picture that I drew. It says, not my picture, but my old notes. It says, we can prove it for real now. Did we not prove it for real the last time? Oh, I guess we didn't. We just did it like it was Pythagorean theorems and did kind of an algebraic thing. But I guess we could look at it like, what if we had an isosceles triangle and we dropped in altitude and created those 2 right triangles? Then we'd know that these angles are congruent. Oh, and then we got angle, angle, side, angle, angle, side. So, but that would be saying angle, angle, side. Oh, they share a side in common. Why was I saying we can prove it for real now? Now I'm just trying to think about what in the world did I do back 6 years or something ago. Gosh. I don't know exactly what I meant by that. Let's not dwell on it and keep going. All right, so state which congruence methods can be used to prove these triangles are congruent, if there are any. Okay, so let's take our diagram. We definitely have that side in common as well. All right, look at this angle, side, side. Oh, so that can't do it, but we have a right angle right there. So, okay, right angle, side 1, the marked angle. Right angle, side 1, the marked angle. So I'd probably say angle, side, angle. But, because I think that's the one that appears first. Because, with what's marked up, we could just go ahead and do that. But you could also do, let's see, with putting this in there, and that right angle, we could go, so the marked angle, the right angle, side 2, the marked angle, right angle, side 2. We could also say it's an angle, angle, side, if you looked at it that way. Let's see. Oh, we could do it's a side angle, side, if you wanted to look at it that way. I'd go with that probably, but there's more than one reason, is what we're getting at. Oh, we could say that this is congruent to this, and now it's side, side, side. But like if you're having to do a bunch of work to get to the reason why they're congruent, don't do that. Like with the first one you see, that's the one you're going to use. Okay, this one we know angle M's congruent to angle O, and X, Y, and MO bisect each other. That means N's the midpoint of both of those. So these are congruent and these are congruent. We have a set of vertical angles right here. So I think the first one I noticed is side angle side. Okay, but let's see. You could do angle side angle right there. Like there's just more than one. The point is that there's more than one way. It's like, which one do you see first? Let's go with that. Okay. So let's see what we got on this. So we know this is a right angle. We know this side they share in common. So over here it's like, say we call that angle 1. Angle 1, right angle, side 1. But over here it's angle 1, side 1, right angle. We cannot prove those triangles are congruent. Could they be? Sure. Have no idea. Okay. Triangle A, B, D, and CDB are right angles. So we're going to mark that. Okay, this is the kind where I was talking to you the other day, like I need to, not the other day, today, but you won't hear this till tomorrow, so it'll be yesterday. I have to redraw the ones that overlap, or I will miss something, sure as the world. So we've got our right angles in both. They share this side right here in common, so let me just go ahead and knock that out while I'm doing it. And we also know that AD, so that whole hypotenuse, is congruent to, so I'm looking right here now, congruent to BC. Those are right triangles. There's a leg, there's a hypotenuse. These are congruent by hypotenuse leg congruency. Okay? All right, let's do a proof. Write a 2-column proof for this. What are we trying to prove? That VR is, oh, I like that small highlighter. I might change that to a small one for this little part. Is congruent to SR. So those are the ones I'm looking to prove are congruent. Okay. So what do I know? Is polygon RSTUV. That's weird. Like, I kind of disagree. I would call that polygon STUV, because you wouldn't, by throwing the R in there, it makes it sound like it comes to a corner, because there's no reason to put like a point that's out in the middle of a side as part of your polygon. So I can't believe I never took that out. Hang on, I'm going to take that out in my notes right now. So when you get this, that won't be there, because it doesn't make any sense for it to be there. Because remember, there's only a few things that we can assume in geometry, and one of them is if a line looks straight, it is straight. So, yeah, let's knock that out of there, which means, I know you're always like, Miss Brandt, why do you keep talking when you're doing this other stuff? Well, because if I don't, I'll forget to do it. So I'm changing this to the PDF. We'll save it. We will replace the one that's already there. So when you get this, that R is not going to be there because it doesn't make any sense. Like, it just STUV, that's a polygon. And we don't have to write that down because that's the diagram. It just shows we have a polygon. Okay, so for number 1, what else do we know? Angle S and angle V are right angles, because that's given. All right, so let's go S and V. Those are right angles. All right, now if that's the case, that means those 2 angles are congruent. Oops, can't just put V there, Gwen. All right, so because all right angles are congruent. Okay, what else we got up here? So we did that one. Let's take care of the next one. ST equals VU. All right, now here's the thing. ST equaling VU means that they're congruent. But have I said they're congruent? I have not. So let me go ahead and write that. That means that these are congruent sides. All right, so number 3 was because it was given. Number 4 is because that's the definition of congruency, of congruent segments. I could just put congruency, that'd be okay. But the definition of congruent segments is that they have the same length. And remember, all definitions are biconditional, so it works both ways. Okay? All right, let's see what we're going to do next. Oh, I've got another given. Angle RTU is congruent to angle RUT. Okay, so that's given. All right, so RTU, so this angle is congruent to I already did RTU, RUT. Okay, so that angle's congruent to that, so that's given. Now, if that's the case, then right here I'm looking at an isosceles triangle. And in that, well, I haven't said it's isosceles yet. Right now it's just isogonic. Did I teach you that word? Isogonic is a triangle that has at least 2 angles that are congruent. So, but we know that if you have a triangle and you have some congruent angles, the sides across from those angles are congruent. So I'm going to add that in there. I'm going to say that this means that RU is congruent to RT. Remember, this is the one I just draw a picture of, because if you knew this, then you know that. Okay. All right, let's see what we're looking at then. So that green and fuchsia one, I'm about to get rid of the yellow highlighter, and I'm going to move it and look at it. So, like, say I look at this triangle here and this triangle here. If I could prove that those triangles are congruent, then probably the green and pinkish color side are probably corresponding parts of that congruent triangle. So, oh, I just noticed something. I never needed to say this step right here. I jumped the gun there. Because the reason those two yellow triangles that I've got highlighted now are congruent is because of hypotenuse leg. I don't need that angle at all. So, how about, and I'm going to go back and change this because I realize I don't need to put something in there that's, muddying up the water. What I can say though is that because I know S and V are right angles, then I know that triangle RVU and triangle RST are right triangles. Because that's the definition of a right triangle. Okay, so let's see if I've got what I need. I've said they're right triangles, because if I'm going to say hypotenuse leg, I got to have that. Have I shown RU and RT? RU and RT, right there. There's my hypotenuse. The leg is the VU and the ST. There's my leg. So now I can say that triangle RVU is congruent to triangle RST because of hypotenuse leg congruency, which means, what are we trying, VR? Okay, so VR is congruent to SR. Is that the way they said it? It is, good. So corresponding parts of congruent triangles are congruent. I said, is that the way they said it? Like I didn't, these aren't my notes. Oh, that's kind of funny. All right, so next up on the agenda, let's see. MB, ooh, we got, it's going to take me a second. Let me figure out what it is I'm trying to prove first. So I'm trying to prove that this is congruent to this. All right, I'm going to mark it up, and I'm probably going to go erase a bunch. What I do know is that MB, I know that's going to be congruent to this, that BN is perpendicular to AC. I know that CM is perpendicular to AB. So that kind of lets me know which triangles I'm looking at. I'm going to look at this one, triangle MBC, and triangle NCB. And I'm going to start over here in just a second. Now I am going to do this. Like I'm trying to prove that this is congruent to this. All right. But I'm going to start back. That's just reminding me of what I'm trying to get to. So I'm going to go through here and mark everything I know. So that's given. So MB, again, is congruent here, which on my new pictures sits there and there. All right, so now I am probably just going to put this in one step, which is not like me, but I'm going to do it anyway. And CM is, and mostly just because I'm getting close to the bottom of the page. I don't have a lot of room, which actually, yeah, if I'm going to do it, I might as well go all out. Let's just put them all on the same one. Okay, so there's all my givens. All right, now what I know, BN being perpendicular to AC means that's a right angle. Okay, and CM being perpendicular to AB means this is a right angle. So I can say that angles CMB and BNC are right angles, because that is the definition of perpendicular lines. Perpendicular lines are lines that form right angles when they intersect. Okay? All right, I know this. They both have that side right there in common. So let's throw that in. I know that BC is congruent to itself. And again, you don't have to worry about they're not matching up corresponding parts. Nobody cares. We haven't said the triangles are congruent yet. So that's the reflexive property. Okay, of congruence. Now let's look at this picture. All right. I have a right triangle. This is a leg. This is a hypotenuse. Oh, yeah. We've got those triangles are congruent because of hypotenuse leg. But again, we can't say hypotenuse leg is the reason until you've said you have a right triangle. So let's do that next. let's say that triangle, what would I call it up here? Have I said the triangles yet? I said C and B for an angle. Let's call it triangle C and B and triangle B and C are right triangles. Okay, because that's the definition of a right triangle. Definition of a right triangle is a triangle that contains a right angle. And here's the right angle up in step 2. Definition of a right triangle. Okay. All right, so there's the right triangle part. Have you noticed, I know I'm stopping and switching gears all of a sudden. Have you noticed that there's always 5 things you have to show up? Like, you have to show side, 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 side. Side, angle, side. Angle, side, angle. Angle, angle, side. Right triangle, then hypotenuse leg. Like, there's always got to have those 3 things before you can say the triangles are congruent. And they have to be spelled out explicitly, not just marked up and known. All right, so do we have the hypotenuse? That's the BC. That's the one that was congruent to itself. Do we have the leg? Yep, right there, the first part of that. So I'm good to go. I can say that triangle CMB is congruent to triangle BNC. I want to make sure CMB, B. Yep, that N keeps looking weird. We need to do a better job. So that's by hypotenuse leg congruency. And if that's the case, CM is congruent to BN. Because corresponding parts of congruent triangles are congruent. Okay. So we got left 7, 8. Oh, just 2 more proofs. That's not bad. All right. We got lots of stuff going on. Okay, so we're trying to show that triangle ACF. So we want to show that this big triangle is isosceles. All right, my guess is to show that, I'm going to need to show that AC is going to be congruent to AF. Okay, so sometimes I'll just sort of work backwards, like, okay, here's what I have to show. What would I have to prove to make that true? So kind of like, this is sort of my goal. How am I going to prove that those 2 are congruent? Okay. Well, to get to there, if I could prove that these angles are congruent, I'd have it. So if I could prove that angle C is congruent to angle F, then the angles across, or the sides across from those angles would be congruent because it's in a triangle. So maybe instead of trying to get to there, maybe I'm trying to get to here, because if I do that, oh, now we're cooking with gas. Now we've got a triangle here and a triangle here. So to be able to say this, if I can just prove that that little CBD triangle is congruent to FGE, I think I'll have it, because then I'll have corresponding parts. Okay, so new goal. I'm trying to prove this, and then that'll lead us to all the rest. Okay, so let's see if I can do this. Should I split my gives? I'm going to split them, but into larger pieces than usual. So this and this, because they kind of go together. I'm going to keep those in the same given statement. Okay, so BD is perpendicular to DC, which means there's a right angle right there, but I hadn't said it. Remember, if you mark it, you got to say it. So I'm going to say the angle BDC is a right angle. All right, now because GE is perpendicular to EF, that's a right angle as well. So it's going to be the same reason, so I am going to keep it in here. So GEF is a right angle. And that's because of the definition of perpendicular lines. Okay, so now I've got 2 angles in there. So all I need is a strategically placed side. Let's see what we got in our next line of givens. Okay, so we know that CB is congruent to FG, because that's given. Okay, so CB, that little piece right there, is congruent to this little piece right here. Do I even need more than that? I think I'm good. I don't even think I need that last given, do I? Did I ever, hang on, let me look and see what I did before. Do I really need that? I don't think I need it. I could prove those. Oh, you know what? Oh my gosh. Do you know what I just did? Holy cow, I made a supremely huge mistake. I left that mark in there from when I was talking about it. Oh, Ethan, that could have been disastrous. It's like, because I was like, oh, we need to prove that right there. And I marked it and I never took it out. Oh, man. Okay. I was like, why are they even giving us this last one? I don't need that, but I think I do. So let's say that CE is congruent to FD, and I'll just leave that in that same step. All right, so CE. Ooh, all right, this is congruent to that. All right. Now, I think we're going to have to talk about this segment right here. I honestly do. I think we got to be in there. Because these two make that. Ooh, I think we're back to like chapter 2. So if these are congruent, let's do this. Those segments are congruent. That means that the segments are the same length. So those lengths are the same because that's the definition of congruent segments. Ooh, this is a dandy little proof. And I think I'm going to do a segment addition postulate. I think I'm going to say that CD plus DE is equal to CE, and that FE, or actually I should probably call it EF, because they're in step 1, it was called EF. I think it'll be confusing if, did I, BD, DC, oh, yeah, the step 1 is DC, and I've got CD. Let's make that DC. I think that'll help. It'll help us probably spot things quicker. DC plus, do I have a DE anywhere? No, I think I'm okay there. CE, I got CE on step 3, it was called CE. EF, so EF plus ED. Do I have ED anywhere? I don't, I think I can call it, no, but in step 5, in the same step I'm in, I called it DE, so let's call it DE. And that's going to be the same as D to F, which, have I called that anything? Yep, here in step 3, it's called FD, so let's call it FD. So that's a segment addition postulate. All right, now what are we going to do with all this? Okay, have we said that CE and FD? Okay, we have right here, we've said they're congruent, but we never have said that CE equals FD. Okay, which we know to be the case because of the definition of congruent segments. Okay, now if we're going to come to here and set those equal to each other, which, and you could do either substitution or a transitive property, whichever one you prefer. So I know that DC plus DE equals EF plus DE. Okay. And let's just go with the transitive property. This would be the transitive property of equality instead of the transitive property of congruence. Again, I could have also said, substitution. Alrighty. Now, we never have said that this segment is congruent to itself, but we're going to need to. So DE is congruent to DE by the reflexive property. Which means DE equals DE. Because the definition of congruent segments, holy cow, this is a dandy. No wonder I gave you the whole page on this one. Because now we can take that, come up to here, and we can subtract the same thing off each side because we have stated they're equal. Like, if it's just a 7, we don't need to do that because 7 is 7. But we do need to say that that's congruent to itself, which makes them the same length so that we know that we're subtracting the same thing. So that leaves us with DC equals EF because of the subtraction property of equality. All right. Now what was I was trying to do? Oh, DC. Okay, so which let's make those congruent. DC is congruent to EF because of the definition of congruency. Holy cow. We got a lot going on right here. Okay. Yeah, I've got a lot going on. So now I can mark this side. 1, 2, 3, 4. 1, 2, 3, 4. That's congruent to this. It's hypotenuse leg. Okay. But have I said I got a right triangle? I have not. So I've got to say that triangle, holy cow, CBD and triangle FGE are right triangles. I wrote too big, Ethan, because the definition of a right triangle. Okay, so there's the right triangle part. The hypotenuse is the BC one. Have I said that's congruent? Please tell me I have. That BC was I have to have. I marked it. Where is it? Well, crap. Well, where is it? BC and GF. Why did I mark it? Where is it? Okay, where is it? That was right. Oh, there it is. There it is. Found it. Up in step 3. Okay, so yes, here's the hypotenuse. The leg is the CD one and the EF one. Okay, here's the leg. I can say the triangles are congruent. Okay, I did CBD, so FGE, yep. That doesn't even look like a congruency symbol. I'm trying to shove it in here so much. It's congruent. Holy cow. Triangle, CBD, FGE. Oh my gosh. Come on, pen. Because of hypotenuse leg, that makes angle C congruent to angle F. Okay, I'm just going to come over the side because I can't see the picture. So I'm hoping that you didn't write as largely as I am. I should probably do this all fronts just in case you need the back. So number 14. Okay. What were we going to say? Oh, angle C is congruent to angle F. Okay, so C and F, those are in the same place because of corresponding parts of congruent triangles are congruent. And if that's the case, then AC is congruent to AF because if we know we have a triangle where those angles are congruent, that means the sides across from them are also congruent. And if that's the case, then triangle ACF is isosceles. And that's the definition of an isosceles triangle. All right, now I just took 16 steps. How many? Oh, I did this in. I did this in 13 steps a few years ago. How did I get? Oh. Ethan, 13 years ago, I didn't do this correctly because I said they were congruent because of hypotenuse leg. And at no point in time in my proof did I say I had right triangles. I said that I had right angles. So we did it better today than I did back then. And I'm a little embarrassed that I didn't do it right the first time. And maybe I should be really embarrassed that my students did not catch me either because these are the notes like after I did them in class. All right, let's see what our last one is. Isosceles triangle ABC with vertex angle at B. All right, now the part you need to put in the proof for that given is that you have an isosceles triangle. Oh my gosh. Why can I all of a sudden not spell isosceles? Isosceles triangle ABC. Actually, I was going to say maybe we could just put the isosceles part, but I think we should do it all just to make sure we know where the vertex is. With vertex angle. Oh, let's just do this. Let's say vertex. No, because you're not saying vertex, angle B. Yeah, vertex angle at B. Sometimes when I try to like save myself some time, I end up taking more time because I think about what's wrong with the way I said it when I was trying to save myself some time. All right, now if this is triangle ABC and B is the vertex up there, so we're looking at this big triangle right now. Okay, then I know for a fact that this is congruent to this. So I'm going to go ahead and put that in here. I know that AB is congruent. Oh, that did not look like congruent. Is congruent to CB. Okay, because of the definition of an isosceles triangle. All right, so took care of that one. E is any point on BD. So that's when you drop that. I don't need to put that in the proof because that's in the diagram that goes with the proof. Okay. BD, okay, so BD is an altitude to AC. All right, now remember the definition of an altitude is it comes from a vertex, or altitude, well, there's lots of different altitudes. The altitude of a triangle is that it's a line segment that comes from the vertex of a triangle to the opposite side and it hits it at a right angle. Okay, so, well, actually, that's not the definition. Let me think about this a second. Hang on. It's not that it hits at a right angle, it's that they're perpendicular. So an altitude is perpendicular to the base. So let's throw that in there. So BD is perpendicular to AC. Oh, that was given. And that's because that's the definition of an altitude. Okay, now, if that's the case, we know that angle BDA and angles BDC are right angles, because that's the definition of perpendicular lines. So then we can put, oh, I already did it, put the right angles in it. So definition of perpendicular lines. I'm so glad you wanted to take honors geometry because I'm having so much fun doing all this again. It's been too long. Like I can do this 8th grade stuff in my sleep. Like I miss teaching calculus and the really good lower level honors classes. Like, oh, you have no idea how much I miss this. So you've made my year, Ethan. So thank you very much for wanting to do this. Okay, so all right, let's see where we're heading. We're trying to prove that triangle EAD. All right, so we want this triangle to be congruent to this triangle. All right, so let's think what we can do right there. Ooh, I got one. Okay, so if you look at the big triangle and we've got those, that means that these angles are congruent. Oh, wait, that's not the angle. That's not what I want then. Ooh, hang on though. Let's drop this. And then we can use the things that we know about a right triangle. I mean, an isosceles triangle. So it is isosceles. Wait, hang on. I see something else I can do. Let's do this for a second. I know that ED is congruent to itself because of the reflexive property of congruence. All right. So, what are we going to do? Oh, wait. I think I see it. I don't want to just focus in on that yellow and green one. I want to focus in on this one and this one. Because those two triangles, is that what I want to do? Do I? I'm not sure. All right, I'm going to think through this one. I should probably pause the video and come back and act like I automatically knew what to do, but no, I think I might want to. I think I might want to go this route. So what if we did this? Yeah, I'm not going to go, because I'm looking over here at what I did a few years ago, and I did a hypotenuse leg, but I don't think I want to do that today. I think, now I may take more steps, but where I'm going today, I think I want to say that this side's congruent to itself. So this was B and D, right? Why don't I do this? That B and D, or sorry, B and D, like it's points. It's a segment. Ooh, let's keep that in step 6, because that's congruent to itself too. Then up here, oops, I had the eraser on. Let's put the A and the C over here. Because now I've got enough, don't I? I could do angle, angle, side if I wanted to right there. Okay, so, but if I'm going to do that, I'm going to need that angle right there explicitly written. And I don't think I've done that. Oh, and I haven't said this yet either. How about we do that? How about, oh my gosh, I don't know that I don't think this is the best plan. Angle BAD. All right, let's try this. It's congruent to BCD because if I have a triangle that has congruent sides like that, so it's isosceles, that implies that the angles across from those are also congruent. All right, so that gets, say, angle 1, angle 1. Then I have the right angle, but if I have to say that they're congruent. Have I said the right angles yet? Ooh, I've said the right angles. So now I can say that they're congruent to each other. Nope, not BAD, BDA. What time is it? 5:49? Hopefully I'll be done by 6. I need to go down there and watch the 8th grade play basketball. BDC, because all right angles are congruent. Okay, so I'm going to do this in a different color. So I've got the angle I want, there's another angle I want, the side I want's right there. So I could say that triangle BAD, not BAC, Gwen, BAD is congruent to triangle BCD because of angle, angle, side. And if that's the case, then 1, 2, 3, 4, 1, 2, 3, 4, these have to be congruent to each other. So A to D has to be congruent to C to D because corresponding parts of congruent triangles are congruent. And if that's the case, then these two little triangles are congruent because of side, angle, side. All right, so I'm going to do this in a different color. Here's the side I want. The angle is the right angle, so that's angle BDA. There it is. And then I've got that other side across the bottom. Oh, no, the side going up and down, which sits right there. So I can say that triangle EAD is congruent to triangle ECD by, what did I say, side, angle, side, congruency. Now, I did this in 11 steps. A few years ago, I did it in 12. But I did an angle, angle, side. A few years ago, I did a hypotenuse leg. Again, I never said it was a right triangle. What? Yeah, again, I think I must have been having a rough day that day because I think we're good here. All right. So you're going to have to go with these notes. You're going to have 2 worksheets, and one of them is just going to be proving things congruent. The other one's going to be proofs. So they will take a while because you should not be rushing these proofs. Like, take your time. Like, you just sat here and listen to me, and I do this for a living. These are not easy, and it's hard to back up what you're saying and not just think around in circles sometimes and be like, ooh, I didn't need that. Let's get rid of that. And, don't be afraid to do that. It is fine. We're also going to have a quiz. Have I printed it out yet? Let's see if I've got a quiz on all these sections. I don't have that printed. Let me make sure I can tell you what sections it's on. Where are you? Oh, I gotta go to the Dropbox. That's where all that stuff is. Come on. Where's Dropbox? There it is. So there's not a quiz here. Let's go back to tomorrow's notes. There it is. Yeah. Okay, so there's going to be a quiz on sections 4.1 to 4.5. And it looks like, well, I haven't opened this up yet, but there's 3 days worth of stuff to cover sections 4.5, 4.6. So 4.5 is what we just did. It was the rest of 4.5, but we still keep working with it. And then we throw in section 4.6 that we haven't talked about yet. So there'll be notes there for sure, but a quiz on 4.1 to 4.5. But I guess this may be a quiz that took all period. I'm guessing if I did 3 days worth of it. So there's a lot to go with this. But also, let's see. So I got 3 days for that. Then there's going to be a day to do section 4.7. And then it's going to be starting to review and then take the test. Oh, it looks like there's also, oh wait, is that the same? This is a quiz on sections 1. Oh, hang on. I got something in here. I have a second quiz that's from the year 2018. I wonder if it's different than the quiz you had, because if it is, I'll let you try again, and then we don't have to worry about that bad grade. Maybe you'll replace it and it'll be better. Oh, that would be nice. Yeah. Let me look and see if, it is different. Yeah, that's what we're gonna do. We're gonna try a second quiz, Ethan, so that you have a chance to redeem yourself on that one that you didn't do as well as you usually do. So yes, I found a second quiz that I already have made out for sections 4.1 to 4.2 that I used 2 years before I used this one. And so sections 1 and 2. Let's just do section 4.1. And again, I know you're like, Sprant, you're doing it again. Stop talking to me while you're doing something else. So honors, geometry, quiz on sections 4.1 and 4.2. Oh, this is, yay. That makes me happy so that you don't have to, because I know that's going to bother you that you had, and you'll be like, well, Miss Brent, I need some bonus points. And this way, maybe we don't. All right. Yeah. I think that's good. I'm going to finish the video, get it uploaded. I'll get everything printed out in the morning, and I think I'm going to go watch some basketball. All right. Bye.